All right, here I have the graph of the sine function, and we want to talk about how we can alter those three new words that we learned for sine and cosine: the midline, the amplitude, and the period. All right, so right now, the regular sine function is sitting with its midline at the x-axis. That's the horizontal middle of the graph. All right, if I wanted to scoot that up or down, that would just be an up or down transformation. Remember with x squared, if I wanted to move it up or down, I would just add or subtract. All right, so I'm going to try adding, let's try to add a 3. Okay, that does exactly what I expected it to. It shifted that graph up 3 tick marks. So now the midline is at y equals 3. And again, if I were to subtract instead of adding, all right, that would take the graph, and now the midline is at -3. And the same will work for cosine as well. In fact, with cosine, let's try to see if we can change the amplitude of the function. So let's turn off sine and turn on cosine. And let's talk about the amplitude. So remember, the amplitude is the distance from the middle to a peak or from the middle to a trough. All right, and so that's currently a distance of 1, like from the x-axis to 1. And I would like that to get taller, but also shorter. So I don't want to just shift it up. I want to make it actually taller. That's going to be a vertical stretch. So remember, we accomplished that by multiplying by a number. So I'm going to multiply cosine by, let's say 3, right? And that does exactly what I wanted to. Right now, the amplitude from the midline, which is still the x-axis, up, for the midline down, I have now an amplitude of 3. And remember, you can also make the amplitude shorter by doing a vertical shrink. I could do a number that's less than 1. Let's try like 0.3. I got it very, very flat, right? Small amplitude. The amplitude is now 0.3. All right. And let me take off that decimal point. You can mix and match these transformations just like with regular algebraic functions. So if I added 1 now to this function, okay, the middle of the graph is now at 1, right? That's the the horizontal middle of the graph, but the amplitude is still 3, right? From 1 to go up to that maximum at 4, or from 1 to go down to that minimum of -2, still an amplitude of 3, right? The last word that we learned was the period. Okay, so let me turn back on sine. All right, so we know that our period is equal to 2 pi, right? And that was how long it took sine from the origin to 2 pi. This one is not going to be quite so straightforward because we didn't do horizontal stretches and shrinks whenever we did transformations. This happens multiplying on the inside of the function. And I'm going to show you why we skipped this when we did algebraic functions. When I multiply on the inside of the function, let's just multiply something simple like 2. Okay. What did that do? Okay, so now the period of the function, the black line, pay attention to that one. Instead of going all the way to 2 pi, like the red dotted line, that takes all the way to 2 pi. Now it finishes a cycle by the time it gets to pi. All right, so by multiplying by 2, I made it take half as long for its period. Okay, so it turns out that we're going to take that 2 pi and we're going to divide it by whatever number we put inside the parentheses. We're definitely going to write that down as a formula. Let's head back over to the whiteboard. All right, so let's write down our 3 rules that we figured out by playing around on Desmos. All right, so the first thing we did was adding or subtracting a number on the end to shift it up or down. That changed the midline. So that was where we added or subtracted here this number d. So you can think about subtracting as like d is a negative number. So we're going to say that the midline is going to be at y equals d, whatever value we choose for d. The next thing we did was to alter the amplitude by stretching it or shrinking it. And that we accomplished by multiplying on the outside of the function. So that's going to be this a that's hanging out front. All right, and that changed the amplitude. All right, and your amplitude is going to be equal to that distance. All right, so I'm going to put the a in absolute value bars. It's possible that you could have a negative value of a that would cause the graph to flip over, and that's fine. But the amplitude is always a distance from midline to peak or midline to trough. So since it's a distance, we always want to report that as a positive number. The last one we did on Desmos was that change of the period by multiplying by a number on the inside. Okay, so this is going to be the b. The coefficient of the x, and I said that we're going to write this down as a formula because it goes completely counterintuitive backwards of what we would think. So your period, you're going to take the 2 pi regular period of the sine and cosine function and divide it by that value. Okay, so when we had the number 2 there, it took 2 pi and it chopped the period in half. All right, so this leaves this kind of questionable number out here. This C, this mystery man here that we didn't talk about. Okay, that is going to do a horizontal shift. Right, and it turns out that that number actually has a lot of interplay with that value of b, and it's more complicated than I want to get right now. We know that that can move it around right to left, but we're really going to focus on these three transformations: midline, amplitude, and period. And we'll do that more when we get together in class.